Good afternoon or morning, depending on where you are. My name is Brandon Carter. I'm an application engineer with Ally PLM Solutions. Today we are continuing on with our ST3 series. Today's session will be on using existing 2D data to create new models from both scratch, and also use that 2D data and manufacturing information on existing models, and also how it applies to synchronous technology. If you have any questions regarding today's session, please write them down and send them an email. So we want to look at how we can get this 2D data and use this on our 3D model. One, to create, or maybe just use that manufacturing data to make changes and so forth. So the topics for today's session, we're going to look at bringing in the 2D data in the Solid Edge, whether that's a DWG file, a DXF, IGES, any 2D geometry format there. We're going to take a brief look at manipulating layers, how the layer structure comes across, and some of the tools we can use there to help clean up our geometry as it comes in. We're going to look at the Create 3D tool, which is a tool we're going to use to get the 2D geometry in those dimensions into the 3D model. We're going to look at how we can use those 2D manufacturing dimensions on the 3D model and how that applies to Synchronous, as I said. And also for the sheet metal guys, we're going to look at how we can create a sheet metal part from a 2D flat pattern. So we have this existing 2D flat pattern, how we can bring that in, get our thickness, and then bend those flanges up. And then finally, new with ST3, we want to look at how we can use 2D data on an existing 3D model, whether that model came from Solid Edge or whether it's a foreign format or whatever the case may be. So I have three examples I'm going to show you just to give you some screenshots of what you're going to see here in this session. The first example, we're going to bring in a DWG file. I'm going to show you the wizard, how we can map that, how we want that to come in and look in the 2D environment. And then we're going to look at using the Create 3D tool and how we're going to create that model and use that manufacturing information. Second example, like I said, for the sheet metal guys, we're going to bring in a 2D flat pattern and look at how to use the bend command and fold up those flanges. And then the third example, we're going to look at bringing 2D data to an existing model, like I said, whether it's native Solid Edge or it could be a foreign file or a neutral format like STEP, IGES, or whatever the case may be. So let's go ahead and take a look at these examples. First of all, I just want to step through the translation wizard. Here you see I'm going to open a AutoCAD file, DWG file. And as I highlight that before I click open, if I go into the options, this is where the translation wizard is. You're going to notice that we can have different configuration files set up, and what we're going to walk through this wizard is how we can set up this configuration file. So first of all, I can preview the document. Notice my layer structure also previews. I can turn that on and off. Notice I can change black and white, handles AutoCAD color number 7, I believe it is. Just instantly switches that for us. Also, if we go on to the next page of the wizard, what units are we bringing in? This is going to be an ANSI document using inches, and we can also have it browse to our company template to bring it in as well. And some options there, how we're going to bring in dimensions. We want to bring the dimensions in as dimensions, and how we want to bring in blocks and so forth. So as we go through this, what I want you to keep in mind is if you haven't seen this dialog box before and you are bringing in an AutoCAD file, keep in mind that there are options there to help you kind of open that the way that you want it to be. Most of the time the default's pretty good, but every once in a while you might want to change that, and obviously you probably want to assign a company template to this. As far as the background sheet, what size do I want to bring that in as? Notice my drop-down list here. Over on the right, if the AutoCAD file has model space, model view there, I can bring that in and say how I want to scale that to best fit or whatever the case may be. I can turn that on. If I go on to the next screen, you see on the left is the AutoCAD line type, and the center is what Solid Edge is going to map to that line type, and then the name of what it is in Solid Edge on the right. So if I've opened a couple of these DWG files and I know that I want to make a slight change to the line type, you see I can come in here and hit a drop-down list and just select whether it's dash dot, dotted, or whatever the case may be, whatever I want to map to that. So just keep in mind this is how I can map my line types. If I go next again, here's the AutoCAD color. What line widths do I want to map to those? Don't want to maintain the colors, don't want everything to come in as black. So there's some options there for that. Last couple here, how the fonts are going to map. On the left is the AutoCAD, on the right is the Solid Edge font that's going to be mapped to it. And finally, the same thing with the hatching styles. On the final page of that, you see that I can save those, copy over those to the original configuration file, or I can create a new configuration file. So you can have multiple configuration files, but this file will map all of the settings that we just went through there, so you don't have to go into that again if you don't want to. So let's go ahead and open this up, and it's going to open it up in ANSI template because that's what I had defined in the wizard in the configuration file. And the first thing we want to briefly talk about is some of the layer structure. You know, this AutoCAD file, the title block may be on one layer, and all the geometry may be on one layer, and the dimensions may be on another. But what if we need to move geometry to certain layers to help us clean up? Because what we're going to eventually do is we want to take this 2D data and the dimensions and make a 3D model of it. First of all, I am on the Layers tab. You can see I can create new layers, I can show a layer, hide a layer, and I can move elements. Those are also on the shortcut menu. So what if I want to create a new layer, just for an example here. So I'm going to click on New Layer. I'm just going to call it New so I can find it. Notice that is the active layer now. It has the pencil on it. So if I were to draw, just for a simple example here, maybe draw some shape, add some 2D geometry to this, that is now on the layer. So if I do a show only on a new layer, it's going to turn everything off and keep that layer only shown, obviously. I'm going to show all the layers again, and the final tool that I mentioned there was the move element. So let's just say, for example, that I wanted to let me show those back on. I just undid that. Show all my layers. If I wanted to window select this geometry and say move it to another layer, I just click on the move layer command and specify what layer I want to move that to, and I just randomly pick center line here. So now if I do a show only on center line, you see that geometry now belongs to that particular layer. So just to introduce you to a few tools that you may or may not have noticed inside of Solid Edge. What I want to do, like I said, I want to show you the Create 3D tool and then get this as the model inside the 3D environment. So I'm going to show only on the object. I see that only my actual 2D data is on the object layer, which is nice and clean. But I also want to bring the dimensions, so I'm going to turn on the dimensions. So now I have the 2D geometry and the dimensions shown. And the tool we want to take advantage of is the Create 3D. Now I could window select these, copy it, open a template I want to go into and paste it, but the easy way is using the Create 3D tool, and that is found underneath the Tools menu. So I'm going to go to Create 3D, and it's going to ask me where do I want this geometry to go to, and I'm just going to put it inside the part environment. I have a white one so that you can see it easier on your screen. The white background shows up better. So I'm going to open it up in a white ANSI part. One thing I want to point out, it is kind of a wizard, so it's showing you step by step what you want to do. Also in the options, you'll notice the projection angle. So just as when we create drawings, we can define whether we want to create these drawings from a 3D model as first and third. Same thing here, when we're creating the 3D and bringing these into as a 3D, we can say how we want these views to fold up, whether it's first angle projection or third angle projection. Also, an option, you probably noticed this with ST2, initially you have include dimensions. So if we want to window select these dimensions and use them, you'll notice how we leverage those in Synchronous just in a little bit. So what I want to do is I want to fold principal views. Like I said, we could copy them, and there's also a copy option here, but I want to show you how we can fold these up. So let's just start through the process. So I want this to be on the front view, so I'm going to window select what I want my primary view to be. I'm going to go on to the next and select another view. Now if you see an option up here, it's called Set Fold Line. So what I'm going to do with Set Fold Line is I can tell these views how I want them to fold up, whether it's on center, on edge, or so forth. If I do not use a Set Fold Line, it's just going to fold them up based on the front view and kind of create a box. But I'm going to show you the Set Fold Line. So I've clicked Set Fold Line, and what I'm going to specify is from key point to key point, and I'm just going to create that line saying I want them to fold up there. And finally, we'll go up to the top view, and I window select that, and let's go and set the fold line to be across this direction. So you'll see how that comes together here in a minute. Once I'm done with that, I can just click Finish, and what it's going to do is launch my part template and fold that 2D geometry up. So you see how it's on center, how I've kind of modeled it symmetric by specifying those fold lines, and notice how the top view and the right view are on center with the primary view, the first view I defined. One thing you'll notice over in Pathfinder is with ST3, it's a little bit different, is these Create 3D user-defined sets. The last one here is kind of a user-defined set of all of them. So you notice if I uncheck Create 3D 4, all of them will turn off, and we'll talk a little bit more about that a little bit later. So what I want to do is take advantage of this 2D geometry. And you'll notice I am in Synchronous, so I have the advantage. I can take advantage of the region concept. So I'm just going to select the region. It's going to go into my extrude command. I want symmetry. Now, since I have the 2D geometry to define my top view and my right view, I can select that key point. I don't have to measure. I didn't have to find the extent. I'm just going to click and define that. I can push a region through here. Maybe I want to remove this material through the center of it. I can push, and notice how that material, just by selecting that region, is gone. And finally, you see that there's a hole down in the bottom of it. I can select that top region, and I'm going to say I want to remove that material and just blow that region through the bottom. Now you see that hole. The other thing you'll notice, let me turn off the remaining sketch there. Notice how whenever we first brought in a dimension, they were kind of the brown color, showing that they were detached. Now notice as I modeled it and created the model, you'll see that there are blue 3D driving dimensions. Now you may be asking, okay, well, why did that 8 not attach? I'm just going to delete that dimension, and I'm going to come in there and actually add my own from the top edge to the bottom edge. And notice how that dimension was actually kind of not accurate, right? So somebody kind of cut and run and called that 8 even though the geometry was not 8. So that because that dimension attached, it knew that that was not 8 millimeters, or in this case 8 inches, and it did not attach. So I can make that 8 in this case. So these are the manufacturing dimensions from the model that we have brought over in the Create 3D. So just quickly here to show you how this applies to Synchronous, I have these dimensions at my disposal to make these changes. So if I want to make this change, notice how Live Rules comes up at the bottom. Everything's modeled with symmetry, so I'm getting the same change on each side. Here I did move that bottom face down, so I didn't lock that dimension, so I want to make that 2 again. I could have locked that dimension before. Here we see the dimensions of the hole. I'm just driving these 3D, driving these manufacturing dimensions from the 2D that was come across. There's no wasted effort as those come across. I can also set up formulas. You kind of see the opening here in the center between those two faces. Maybe I want that to be 2 millimeters and lock that down. The other thing I can do is I can actually create a formula to maintain my design intent. So if I want, let me go ahead and make that 2. I didn't type that in. If I want this to remain half the distance of the overall length, I can set up a formula. So I have that dimension locked. I'm going to go ahead and lock this 4-inch dimension. I keep saying millimeters, I'm sorry, 4 inches there. And what I can do is set up a formula on this 2-inch dimension like we're used to. I can just right-click on it and say, let's edit a formula. And I already have that locked. So what you're going to see is that those are locked. And if I want to make a change to those, I can make that change and show you where the edit formula. My screen wasn't updating, but I can say edit formula and set that in to be half as much. So what we did there, like I said, just to get it introduced there, we took 2D geometry, we brought the 3D driving dimensions over, and notice how everything attached. The next example we want to take a look at is of a flat pattern and bringing in a sheet metal environment. So let me open up a different 2D file. And what I'm going to do is come in there and open a DXF. In this case, you know, somebody might have had a DXF that this part was made, maybe it's out on the cutter in DXF format. We're going to bring that in. I'm going to use the same options because this is an ANSI file. And you see here I just have the flat pattern. I have my bin center lines. Now using the same tool, Create 3D, keep in mind the radial buttons new with ST3. I actually have Create 3D. I use that tool quite a bit here. So I have that mapped to my radial button. I'm going to use the Create 3D. We're going to create a new file once again. This time I'm going to use the sheet metal environment, and like I said, I have a white template for that. And what I want to do in this case is I want this to be on the top view. So this is the only view I'm going to define. I want this to be on the top view. So notice in my Create 3D tool I can define that. And I'm just going to window select that view, and that's going to be my only view for that. So now that comes across in my top view. Now it's really nice here in Synchronous because I can take advantage of the region concept and pick all those regions I could have window selected and did it that way as well. And I am in sheet metal, so I'm just going to say create a tab in that direction, and it's going to do my default material thickness. Keep in mind, it is sheet metal, so I am using my material table, my gauge thickness, in this case 38 thousandths, which is what this default template was. So notice I still have those bend center lines, and what I can do is use the bend command, and I can just select those center lines. And inside the bend command, you're going to notice some options here for how it's going to be defined. So here, this default is center of fold lines, and what that allows me to do is that it's going to be on the center of the bend. So there's going to be material on each side as it bends. Mold lines will allow me to pick which direction I want material inside or material outside. I'm going to leave the default bend center lines, or I'm sorry, center of mold lines. And I'm going to say which side is going to move. I'm going to pick the far direction, and then which direction it wants to fold. I'm just going to leave 90 degrees as my my bend angle. I've put that on my radio button as well. Excuse me. So I'm going to select the bend, and I'm just going to go around here and quickly bend these flanges. Once again, easily accessing my radio button. Also, if I pick the bend first, notice how that's alright. If I pick the geometry first, I can go to the command. It can be object action or action object as far as the command goes. So I'm going to select my final one, say bend that down, and you see just from taking that flat pattern and create my tab, I can use the bend command, and I have my formed part now. If I want to get back to the flat here in the 3D, just with 2 clicks, there's my flat pattern again. So just keep that in mind. That's using the bend command is an easy way to get from that flat, that 2D flat, to the 3D model. Finally, we want to look at some brand new tools here with ST3. And what if we want to use existing 2D data on, or I'm sorry, you bring 2D data in and put on an existing model. So here I have a SolidWorks part. Maybe that's a step, whatever the case may be, ParaSolid, another file format. If I bring this in, I'm going to open this up in the part environment, just like I've translated a file. Maybe I've downloaded this file, whatever the case may be. And you see I don't have a history tree, I don't have any geometry, and as you've seen with synchronous technology, yes, I could go ahead and start placing my own dimensions if I wanted to make changes to this. But what I want to do is bring across manufacturing information from a 2D drawing to this 3D model. So I'm just going to save this particular file. And let's go ahead and open up the drawing that came across with this. This drawing happens to be a DWG as well. And I have a different configuration file. We talked about mapping different configurations files. I just have this map, so it's set up to millimeters in an ISO template. That's the only reason why I changed there. I'm going to bring this in. And the same thing as we looked at before, we're going to use the Create 3D. But in this time, instead of using the Create 3D to create a model from scratch, we're going to use Create 3D to get this information over to that model that we just brought in from SolidWorks. A couple things you see, we have a top view, a front view, an auxiliary, a right, and a detail, and an isometric. So we want to take advantage of all these manufacturing dimensions in these views. One thing I want to point out is the scale of the view, 1 to 5, and also this detail, it's 2 to 5. So that's going to come into play when we look at some of the other options inside the Create 3D tool. As far as turning on and off layers, we already talked about that. I'm going to turn off these particular layers and just leave the geometry and the dimensions on. So now in the Create 3D with ST3, you see that we have a new option to add to an existing file. So what I can do is just browse to that file that I brought in and saved. And same thing, we saw the options to include the dimensions, which I'm going to. Now, when we fold the principal views, keep in mind the scale. So we said that it was 2 to 5. Now, so as I scale that, I want to type in a 0.20. And remember also, because I did the sheet metal part, I changed it to top view. I probably want to put this back to a front view if I'm going to window select this one first. So I'm going to window select the front view and all its dimensions. Notice how they select, or they all highlight. I'm going to go on to the next view. Now I'm not using the fold lines like I did the first time, because here I wanted to kind of create a box around my model, which you will see. So I've selected those. They're all at a 0.20 scale. Finish that. It's going to put it on top of the model which was saved, and notice how they line up and how the Create 3D put those views aligned to each other. That's what it'll do when you do not set the fold line. So if I look at a front view, you notice how those dimensions and those views are lined up. If I look at a top view, same thing there. and also finally a right view. We see how those have updated. Once again, as I mentioned earlier, the Create 3D, this bottom user-defined set is a cumulative of them all. So I can uncheck that bottom one, and that will turn off all the others. I want to look at these individually. So I'm just going to turn on the Create 3D 1, which is the primary view or the front view. You'll notice that I can right-click, and there's a new tool in ST3 here called Attach PMI. So notice how those PMI dimensions kind of migrate or jump to the model. So now those manufacturing dimensions from the drawing are tied to the model. So this is truly a synchronous 3D driving dimension. If I want to make a change to that one, that arc down there, I'm directly driving the model. If I want to take advantage of my synchronous live rules, I can drive that dimension, and notice how coplanar axis is moving the hole above it as well. If we take a look at the other views, I'm just going to turn on the right view and kind of look at them one at a time just so you can see how this is working. I'm going to attach the PMI there again, and notice if I change this 25.4 dimension, notice how it's changing the other side. The other side is getting longer too because of coplanar and also symmetry in this case. So maybe I want this to be 35. The top one, let's go ahead and just right click and attach the PMI of that one as well. And you'll see that I can also take advantage of synchronous lock dimensions. So if I want to lock down this 25.4 so it doesn't move and then drive this dimension, notice how the 25.4, the width of the rib is not moving, and I'm driving this to whatever I want it to be. You'll notice that because of the symmetric live rule, the other side is moving as well. All right, let's take a look at the auxiliary view. I'm going to switch back to the draft. Remember, we had an auxiliary view and a detail. Let's see how we can leverage those as well. So I'm going to go into the Create 3D tool again. This is still a 1 to 5 scale. I'm just going to window select this one auxiliary view for now. And let's bring that in. And notice how it brought it in as a front type view, right? Well, we can use our steering wheel and rotate that and position it. Keep in mind the steering wheel is very flexible, not only for moving faces, but moving 2D geometry as well. So if I want to rotate this around, make that 90 degrees, make that normal to where I want it, and then I can snap my steering wheel. And we talked a few weeks ago about our how to manipulate the steering wheel, and our from point being the origin of the steering wheel, and our to point. And what I want to do is just say move it in plane so it lines up with this hole. So now it's lined up to it. Maybe I want to move it up to the face. I'm going to use my secondary axis, and notice how we can move it up to that center point. So it's very easy to manipulate that 2D geometry as well as 3D faces. If I want to right click and say attach the PMI, notice how once again those are now migrated to the model, and we can use those as driving 3D dimensions. The final view, if I switch back to the draft file, remember I said that this one was a 2 to 5 scale. So when I do my Create 3D, I need to come in here and change this to 0.4. So I can window select that, click Finish. Once again, it's very easy to manipulate with my steering wheel. If I shift select or shift click inside the torus, that'll flip the steering wheel over for me. If I shift click on the origin, you see how I can move that up and dock that to that endpoint. Let me zoom in a little bit so you can see that. So I get the endpoint feedback. So I've placed my steering wheel where I want it. Now to actually move it, if I click inside the tool plane, I can move that kind of X and Y, so to speak, and line that up very quickly. If I right click now, I can attach the PMI, and once again those are 3D driving dimensions. So those were the 3 examples we looked at. So what we did in these 3 examples, we brought the 2D data into Solid Edge. We looked at the options there as far as the wizard for how the data is going to come across and how it's going to map. We also looked at a little bit how to manipulate layers, show hide, how to move stuff from layers. We also, in the other examples, we used the Create 3D tool. We used it to create the 3D model from scratch, and then take that manufacturing information and use those driving use the manufacturing information as a driving dimension. We also looked at how to create a form sheet metal part using existing flat pattern, so that 2D flat pattern to a 3D form sheet metal part. And then finally, new in ST3, how to place 2D data on an existing model. So the new option that says apply to an existing model. So we took that that manufacturing information and took those driving, or took that manufacturing information and made driving dimensions on an existing model. We're about out of time here, but just to remind you, replays can always be seen at YouTube. So go to www.youtube.com/AllyPLM, our channel there. Just coming up over the beginning of the year, our class offerings, ST3 fundamentals for new users, January, February, March, and then the update class for ST3. You see the dates there. If you want to look at other classes or check out those dates in a little more detail, you can go to our website there. Also, any webinars, future lunch bites, please check out our website. Thanks for your attention this afternoon. I hope you found this session informative. Please email your suggestions for future Lunch Bytes topics. Also email us any questions you may have had during this session. Yeah, please let us know your questions. If there's anything regarding this session or anything your day-to-day activities, please let us know. Our next scheduled session will be on patterns. We're going to look at some of the new synchronous patterns, the fill pattern, and just look at the different patterns there. So thanks again for your attention, and have a great day.